Alright, this is section 2.5, graphs of tangent, cotangent, cosecant, and secant functions. What I did here is I basically gave you a graph, an image to look at while you look at the properties of these. We've briefly mentioned these properties, so these should be a little bit familiar to you. But if you would, just take your time. You can print a copy of these videos out to just, actually the notes, I saved them in the PDF. So you can look at the domain. This is your x values, all real numbers except odd multiples of pi halves. So negative pi halves, 3 pi halves, so on and so forth. That'll be where it's a vertical line, undefined. That's your vertical asymptotes. The range is your y value, so negative infinity to positive infinity. Period is just a pi because one cycle occurs in pi units, so you can see that there. Goes to the origin, and when I say increases to the right, I mean when you start on your graph and you move to the right, you can see my arrows going up. Cotangent function, similar except for they have the domain has vertical asymptotes at multiples of pi. So the dotted lines, the vertical asymptotes are at pi, 2 pi, 3 pi, so on and so forth. The range is the same. Odd with origin symmetry, we talked about this in class and I gave some examples to where, and also this does not go through the origin right here. And it decreases to the right. What I mean by decreases to the right, when I get on this function and I move to the right, my arrow is taking me down, so it's decreases. Period of pi. Like I said, you can print this out and spend a little more time on it. I'm just briefly running through these. Cosecant x, the domain, all real numbers. This black is actually just sine of x. Remember, cosecant of x is a reciprocal function of that, and we're going to heavily rely on this when we graph some other examples that aren't parent graphs in this next few videos. But we can use this parent graph to help us get a sketch of this reciprocal function. But this range means negative infinity to 1. So really it's just the blue graph. So we're saying from 1 to infinity, or from negative infinity to negative 1. So that's where your range comes into play right here. This is interval notation form. Vertical asymptotes occur at pi, so pi, 2 pi, 3 pi, period of 2 pi, just like its reciprocal function. All right, let's move to secant x. It's the reciprocal of our cosine function, so basically we took the parent graph of cosine of x, it's this black one, and we used it as a guideline. This is our reciprocal function. So all values of x except for odd multiples of pi half, so that's where our vertical asymptotes come into play. And then the range is likewise, so from 1 to infinity, that's y values. Negative infinity to negative 1. That's represented right here in interval notation. Even with y-axis symmetry, basically that means if I folded my piece of paper right here in half, they would match on each side of the paper. Period of 2 pi. So one full cycle of cosine happens in 2 pi, so with the reciprocal function, that's also going to be a period of 2 pi. Okay, so our first test is to graph 5 cosecant x. And one thing off to the side I want to recall that cosecant x is 1 over the sine of x. Okay, so what I'm going to use is I'm going to use my sine of x to try to help me get an idea of what this is going to look like. Now granted, with every single one of my functions, I can set up an XY table like in the last lesson and do all the algebra and calculate it. But we have an easier option in this case. I can take, and this just means an amplitude of 5, so let me write my general form. Okay, so y equals a cosecant omega x. This is where our amplitude is going to be. Amplitude would be 5, and period is 2 pi over omega. which that would just be 2 pi. In this case, our omega is a known 1 is right there, so it's just 2 pi over 1, which is just 2 pi. So that means 1 revolution in 2 pi. Well, we know what the graph of the sine of x looks like, right? So if this is, let's just do a rough sketch. This is pi and this is 2 pi. Then the sine of x, amplitude is 5. So we could throw this sketch out here. It's going to just be okay, rough sketch, right? Our sine of x, this is a little bit off. So sine of x right there. Now, what I can do is I also know I have asymptotes for cosecant x at. Alright, so I'm going to go ahead and draw vertical asymptotes in. Also, it's where it crosses the x-axis, where your graph crosses the x-axis right there. So if I was to do that and extend vertical asymptotes, I can graph my 5 cosecant x by coming here and sketching up. Same thing here. Now, let me go back a little bit. This should approximately touch, because that should be at 5, right? Amplitude of 5. And so the red is the graph of y equals 5 cosecant x. So what we did is we used our sine graph to help us sketch the other one. Now if I wanted exact values, I'm just going to try to do a better job with this. If we wanted exact values of these, we would make an XY table just like we did with the sine and cosine lesson, and we would get the same kind of values. We would get pi halves, the ordered pair pi halves 5, the ordered pair 3 pi over 2, negative 5, so on and so forth. So you have some options there. So I'm going to show you using the parent graphs and the reciprocal functions on these for sketches, but feel free at any time to do XY table. Okay, our next one is y equals negative 3 secant of x over 2. I'm going to recall that secant x is equal to 1 over the cosine of x, so I'm going to use my graph of cosine of x to help me plot this. Now I need to account for the amplitude and the period, so let me write my formula down and then determine amplitude and period. Okay, my A is going to be absolute value of negative 3, which is just 3. We also have a reflection because of that negative sign. So you have a reflection, we have an amplitude of 3, and the period is 2 pi over omega. Omega in this case is just a known 1/2. 1 here over 2 1/2 pulled out front, so omega is 1/2. We plug omega in, multiply by the reciprocal, which is 2, so you multiply this by 2 and you get 4 pi. So we have all of our characteristics. Let's draw a rough sketch of cosine of x. Negative 3 cosine of x first, x over 2. Okay, so all I've done so far is a negative 3 and a 3 for my amplitude, and then I know a period is 4 pi, so to go through one cycle it's going to be 4 pi. The other thing is by my vertical asymptotes, by my domain for secant x, is going to be all real numbers except I multiples of pi over 2. So I multiples of pi over 2 are going to be vertical asymptotes. So that's roughly that's for the parent graph, but in this case we have some shifts and things going on. So first let's just sketch our cosine graph. So it's a reflection. So typically, remember, cosine goes like this, but since it's a reflection, I need to keep in mind that it's going to be reflected here. Whoops. Let me okay, so it's going to look like that. That would be our negative cosine of x. So what we want to do is, remember, we need to do our vertical asymptotes everywhere it crosses the x-axis. Whoops. Thought that was a x-axis at 0, so that means there's a vertical asymptote here, and there's a vertical asymptote here. Okay, this dotted line is going to be our negative cosine of x. So we want to do the secant x, so our red is going to be just going to be our graph of secant x. Negative 3 secant x. Okay. Also, just a reminder, you can do that table. So let's say if x is pi, because remember it's 4 pi, so if I divided it in equal increments, each increment will be pi increments. So when x is pi, this is just one particular example. I plug pi in right here, which would give me pi halves. The secant of pi halves is 1 over the cosine of pi halves. So go to pi halves and do 1 over the cosine of x. Well, that becomes 0. So then negative 3 times 0 is 0. So at that case, pi halves is 0, or in our case, 1 over 0, which is undefined. 1 over 0, sorry, I put 0 there. So 1 over 0, because that's 1 over the cosine. So that means it's undefined, so that's why here we have an undefined line. This is to do the algebra behind it. Like I said, it'll be consistent, so that's up to you.